Hello everyone, my name's Eunice, and today I'm going to be showing you guys how you can program a stepper motor and control it with a push button, and this is going to be done all through Arduino. So with that, let's dig right into it. I got a little PowerPoint presentation for you guys, and you can follow along with it. It has the code. I'll post the code in the end of the YouTube video. So if you guys want to implement it, you guys can copy paste that code and then set it up as well. It'll be linked to my GitHub. Thank you very much. So I'm just going to transition into the PowerPoint slide. You may have noticed I disappeared, but don't worry, I'm here. So the first thing I'm going to be showing you guys is the wiring sequence diagram, the parts you're going to need, and then we'll talk about how they're set up, how they work, and then how they're coded. So this is all going to be done in 14 slides. So with that, let's dig right into it with the parts you guys are going to need. The parts you guys are going to be needing for this experiment would be a computer. This computer can be any kind of computer you want, just as long as it can run Arduino IDE. So even on a Raspberry Pi, if you want to, you could run Arduino IDE and you could program it from there. The next component we're going to be needing is Arduino, and that's going to be the microcontroller for our operation, or we can also call it the brains of our operation. The next part we're going to be needing is a push button. That's just something so the user can press on and it will rotate the motor accordingly. And so with that push button, we're also going to need a 10k ohm resistor. That I'll explain later on why we need it, but for now we do need it. It's very important. And finally, we're going to need a 5-volt stepper motor and a driver to go with it. Typically they will come in a kit, so you guys should have everything there. So this is the wiring diagram right here. If you want to follow along with it, you would have your push button, and then on the push button you would connect it to a 5-volt source and a ground on the other, and you want to put a push button in between the ground and the push button. And then on the ground side of the push button, you're gonna have it connected to a digital pin on the Arduino so we can read the push button. And finally, we're going to have the stepper motor. And so for the stepper motor, it has 4 poles, and that's going to be connected to 4 pins on the Arduino. And the IC is just going to be powered by the same 5 volts and ground, same as the push button. Since we're using a bunch of components, I just want to talk about how they work and what's going on behind the scenes that's making the code work the way it is. So the first thing we're going to be taking a look at is the stepper motor, and so the stepper motor is called a 28BYJ48, and so it has 4 coils, as you can see, and it's represented by 4 pins, and we're always going to be feeding 5 volts into the stepper motor, and so the coils are going to be acting as a ground. So every time we're programming, we're going to activate one coil. So what happens is there's going to be electricity that gets sent through the stepper motor, and whichever coil is open, it'll release from there, and this in turn will cause the shaft of the stepper motor to rotate 1 step. And so a fun fact about these stepper motors is that there's to do 1 whole revolution, it's 2048 steps, which is a lot of steps. But stepper motors are very good because with that many steps, you can have a really good amount of precision in your experiment. With that said, with the stepper motor, we're going to be needing a driver IC that can provide it enough current. And so for that, we're going to be using the ULN2003 IC. This will come together. And like I said, it's pretty much plug and play earlier. So the stepper motor gets connected to the white channel right here, and then you control it with 4 pins over here that go straight to your microcontroller. And then you power it by a 5-volt and a ground here as well for the IC and these LED lights. And these LED lights are so helpful because they can tell you exactly which coil is active. So then you can visually get a confirmation, because it might be hard to tell by 1 step which one is moving. So this is really helpful for that case. And the very last component we have left is the push button. And so for the push button, I sort of explained it earlier, but we have a 5 volts going into the push button, and then we have a ground connection that's going to be connected at the bottom, and then we're using a 10k ohm resistor. The reason why we're using a 10k ohm resistor is if a user was to just press down on the push button, what would happen is 5 volts gets in, and then it'll travel across, and it'll go to the ground right away if we didn't have that. And so what this will cause in turn is short in our circuit, and this will cause the Arduino to shut off, and we don't want that happening. And on the top end, so the push button is connected in lines, vertical lines like this and like this. So basically this is connected to the ground. So when you press a button, it's going to get a reading and it's going to send it to pin 8 on our Arduino. So this is why we have it configured the way it is. So that way we're avoiding shorting and we can get the user input. And then so now you guys have a really good understanding of how the hardware works. Now we're going to be coding it and implementing it to make it do what we want it to do. So let's dig right into the coding portion of it. And the first thing we're going to be talking about is just loading up your Arduino IDE. So wherever it's configured, load up your Arduino IDE. And right off the bat, whenever you launch Arduino, you'll have like the preset void setup and void loop. So in the setup, your code will only run once. This can be used to like initialize like, hey, on like these pins on my Arduino, I want it to do an output, and on these pins, I want it to do an input. So we'll configure that in setup, and then in the loop function, we'll have our program keep running over and over again, just waiting for a user's input and then controlling the motor according to the user's input. Perfect. So this is the variable declaration we're going to be using. There's a few important ones that we need to be mindful of. So here we declare M1, M2, M3, and M4. These are going to be the variables for the coils on the stepper motor. And then the step number is going to be the step counter. So we're going to have 4 steps in our code, and each step is going to activate one of the coils. The next one is going to be a push button, and that's going to be connected to pin 7. And then all these are pretty much for the push button, and it's going to be using debouncing, which I'll explain a little bit later on. And then spin of the motor direction is just going to be which direction we want the motor to rotate after a button press, and it'll keep changing. And then motor spin time is how long we want to spin the motor for. And then the previous and active and was button pressed, this will be used later on in the code, and I'll explain that shortly. The first thing we're going to be setting up is the setup function, pun not intended. But so for the setup function, we're going to have our 4 coils on the stepper motor. We're going to declare them as the output, and then the push button, we're going to declare that as the input. And then we're going to just bounce right into the button press code. So this button press code is derived from the Arduino examples, and it's the debounce examples. So on your Arduino IDE, there's some examples you can use just to learn a bit about it. And so this is primarily just brought from there. So first thing we're going to do is we're going to define a function that's going to be listening for the button press, and we're going to assign a variable called listening, which is going to just read for a button press. And so over here, we're just checking when the last time a button was pressed, and then we're going to start a timer for it. And so what we do is we use millis, and then we have a little delay. So this delay is used for if a person was to push a button, like if they press it really quickly, it might not register it, or it might mess up our code and it'll make the motor constantly rotate back and forth. So we use debouncing, and then we also check that, hey, like whatever we're listening to is not like the same button state. And then afterwards we check if the button state is actually high. So if a person's pressing the button, what we do is we alternate the direction of the spin button, of the motor direction, and then we activate a timer for the current time the Arduino is at. And then we also check was button press true, and this will be used later on to update a variable to make the motor rotate. And so you might be wondering, why is this so complicated? Because realistically you could do it in one line, and that would just be listening equals to digital read, and then you can assign it to just be equal to the variable. And if it detects like, hey, a person pushed a button, activate the motor. Realistically, this can be done in like 2 lines, but it's just to reduce the noise. And so we want to just keep consistent with that scheme. And this is going to be very efficient in that sense, where it avoids unwanted input or just like noise that's interfering with the microcontroller. It'll just void that out. Oh, so I accidentally went forward a few slides, but we're back on the right one. So the next method we're going to be creating is called the stop motor. And so what stop motor will do is whenever the motor is rotating after a certain time, in our loop function we'll call a stop motor command. And so what it's going to do is it's going to set all the pins or coils on the stepper motor to low, and this in turn will cause our motor to come to a complete halt. So now we're going to be getting on to the fun part, which is moving the actual motor. So what this method will do is it'll basically get an input of the direction we want to rotate the motor. And so if the rotation is true, it'll rotate clockwise, and if it's false, it'll rotate it counterclockwise. And then what we have set up is a switch statement, and so the switch will be the step number. So in our stepper motor, since we have 4 coils, we're going to have 4 different steps that are going to be unique. And so what this switch statement will do is it'll run through different steps. It'll activate coil 1, then it'll activate coil 2, then 3, and then 4. And at the end we'll have basically a counter for the step number, and when it reaches 3, it's going to reset back to 0, and it's just going to start all over again from case 0. And so the main difference between clockwise and counterclockwise direction is just the order of the steps. And yeah, so if you want to just learn a bit more in detail, you can visit this YouTube video tutorial that helped out in understanding how a stepper motor works in further detail. And so one thing that I want to point out is Arduino actually has a stepper motor library, which can make your life a lot simpler. However, with the stepper motor we're going to be using, it's not compatible with it. So that's why we have to go the long route and pretty much code every single step manually. But otherwise, if you have an appropriate stepper motor, you can just use this library, and it'll save you a lot of lines of code. And so for the last part of our code, it's just going to be the loop function. And in the loop function, it listens for a button press, and if a button press was detected, what we do is we start a timer, and from the active motor spin time that was handled in the listen for button press, if it's less than the motor spin time threshold, which is 2.5 seconds in our code, we spin the motor, and then we have a delay of 2 milliseconds, and that's just for the motor to physically move. Generally we want to avoid it, but 2 milliseconds isn't gonna hurt our code in any sense, so it's okay for that. And then after we pass the motor spin time threshold, all we're gonna be doing is we're gonna be stopping the motor. And so one question you might be wondering is why we are using millis. Millis is just like a little cheat sheet to threading in Arduino, because we don't actually have threads. So what we do is we use millis, which is a built-in timer in the Arduino. And so it starts the moment you plug it into, and can run for 45 days. Like, it's a whole clock that goes by a 45-day cycle. So we cheat and we time our code so it goes by millis, and so that way we can do multiple things at once, and we're not getting our code caught up in a delay. So yeah, that's why we're using millis. And so for the end result, I will show you guys what it looks like. And so at the end, if you followed along, this is how it would work. So you press the button, and then it'll spin the motor for about 2.5 seconds. And then if you press the button again, it'll spin it the other way for 2.5 seconds.